Hello, I'm Robin Ince.
And I'm Brian Cox.
And welcome to the podcast version of The Infinite Monkey Cage, which contains extra material that wasn't considered good enough for the radio. Enjoy it. On my left, a man who's seen things you people wouldn't believe. Attack ships on far off the shoulder of Orion, sea beams glittering in the dark near the Tannhauser Gate. He is, of course, Professor Brian Cox.
On my right, a man who's experienced delays between Stevenage and Grantham due to points failure at Peterborough. It's Robin Ince. Today we're going to talk about the history of life on Earth and the history of the Earth itself. After 8 series of endless physics, particles, muons, gluons, quarks and probability, finally we get to the science. You wrote this, didn't you?
Yeah, I did. Yeah, it's real science. This is dinosaurs. And you may say, oh, but they didn't have a space program. Isn't that just what you would say? Anyway, dinosaurs are better than physics.
He took my joke, didn't he?
I'm just trying to speed it up.
He took my joke from the...
OK, you can do it. I'll let you do it. I'll let you do it.
No, there's no point now, is there? Because I've done it once anyway, and now you've done it again.
That joke if I were you.
Yeah,
Beyond the dinosaurs, we'll be digging down into the soil beneath us and seeing how the rocks below create a time machine, a vision of life and a changing planet that allows us to understand that the Earth is 4.54 billion years old and has a fascinating history. Dave Martell is a professor of paleobiology. He was an advisor on Walking with Dinosaurs and is an expert on mitochondrial DNA and dinosaur sexual behaviour.
I didn't know that.
Is that not true?
No.
It says it on your website, your university website.
Did it? I'll have a word with the IT people. I know a little bit about sex in dinosaurs.
But that probably means you know more than almost everyone else. To know a little bit about the sexual behaviour of dinosaurs still puts you in the lead.
Do you think we'll ever get to the end of the introduction? Hermione Coburn is a geomorphologist and was presenter of BBC's The Fossil Detectives,
which later changed its name to New Tricks.
Is this a real show? Is this actually a real show?
It's not normally.
Because I've seen you do stand-up and I've seen him on volcanoes and that, but this doesn't seem legit.
No, it's not at all.
It's all in voiceover, my stuff.
Ross Noble is Twitter's very own littlest hobo, going from town to town and place to place on the whim of his followers. Starting in stand-up as a teen, he was something of a child prodigy. He's now an inner child prodigy, refusing to allow his inner adult to in any way take charge of his life.
Oh, that was me. Yep, lovely. Yep.
Now, it could be said our final guest needs no introduction, but that'd be poor radio, because you'd be sitting at home thinking, I know that voice, but who is it? We're always keen to support emerging talent.
He's just starting in the business very much.
So we're giving him a little leg up in his career. It's Eric Idle, and this is our panel. Hermione, the understanding we have of the processes that formed Earth today, and I suppose the age of the planet, we quoted that number, 4.54 billion years, very precise. But it's relatively recent that we built up that picture, isn't it? So can you run through the recent history of geology?
Well, there are so many different ways to answer that question. But I think if you're looking at kind of the start of geology as a really systematic science, I think you probably have to go back about 200 years. To the end of the 18th century and to James Hutton. And he was a Scottish geologist, but I sort of hesitate to say geologist because actually he was more than that. He was a farmer, he was a naturalist, he studied medicine at Edinburgh University. So he was very practical as well as academic. And what he did by looking in the landscapes and the rocks around Edinburgh was really challenge the notion of a young Earth. Because at that time, there was this idea that the Earth was probably created about 6,000 years ago. And this all came from sort of the religious framework of the time. But what Hutton did was he said, look what's in the rocks. There simply isn't enough time in 6,000 years to explain what you can see. And what he saw was phases of uplift, long phases of erosion and sedimentation, and all the geological processes that we now know go on and take a very long time. So I suppose he was really the first person to open up the vastness of geological time. And then you had people like Charles Lyell coming in. I mean, I suppose he could be argued to be the start of geology as a science. But that early 19th century was the boom time for geology.
And it's interesting that if you look back, it sounds like a long time ago, but in fact, in the scientifically speaking, I suppose it isn't. I mean, it's a long time after Newton. It's a long time what we consider as modern science became successful and a successful explanation of the world. So why is it that geology seemed to stay outside that framework for so long, do you think?
That's an interesting question. Maybe it was the confines of sort of religious teaching at the time. I mean, Hutton wasn't afraid to challenge the establishment.
Sorry, could I suggest it's because rocks are really heavy to carry back to a lab, and people probably picked them up and just went, nah, let's not bother. It's probably that.
But before Hutton, people really hadn't any clue of how they would even answer the question from rocks. So Bishop Ussher, Bishop of Dublin, he actually, although everybody sort of knocks him because he had a very different approach, he determined the age of, 6,000 or something. He actually used the only methodology that was available to him. He simply used the Bible and various manuscripts, and he simply sort of, well, so-and-so begat so-and-so, and they begat so-and-so, and eventually, if everybody lived sort of 30 years or whatever it was, he was able to put a chronology on it. So that was actually a serious scientific attempt to date the Earth. But of course, because it came from a bishop and everybody was religious, that was accepted. That then became a dogma, and then it needed people like Hutton, like Lyell, like Buckland to break that dogma.
Our understanding of life on Earth ran in parallel to this in some sense, didn't it? Certainly fossils, fossil collecting as a collecting hobby predates those times by a long time. But when did the beginnings of the scientific appreciation of fossils begin?
Greeks were looking at fossils, and Greeks realised that fossils represented the remains of once living organisms. But then it went into a sort of a dark ages, and it wasn't until the middle of the 1700s that people were describing fossils in a scientific framework. The first scientific description of a dinosaur bone is in the middle of the 1700s. And then in Germany, a guy called Collini, he was a lawyer from Florence, he described the very first pterodactyl, and he did a really good scientific description of it, not knowing what the animal was. And he described that in something like the 1780s. So it's around that time in the age of the Enlightenment that people started to describe them, even if they didn't understand them. The first person who really took dinosaurs out of the scientific literature and brought them into, say, into a novel was Jules Verne. With Journey to the Centre of the Earth, and he was the first. He had a battle royale between an ichthyosaur and a plesiosaur, and that made them very, very exciting. It was very, very accessible to the public. There was also, of course, the Great Exhibition in London in the 1850s in Crystal Palace, when big models of Iguanodon and Megalosaurus were made, and that is where they were taken from, the depths of scientific literature that were only accessible to a few, all of a sudden into the public domain. And then, wow, all of a sudden dinosaurs were sexy and have been sexy ever since.
See, I knew you'd know all about that sexy dinosaur stuff.
And is that why it was called a plesiosaur? Didn't do anything for you, that one. There's one, come on!
And for the listeners at home, Ross is currently juggling his breasts in that mine.
That's what Branagh should have done on Walking with Dinosaurs. And here comes the plesiosaur, ready to please the other dinosaurs. Can you answer me this, right? How comes it was always the Diplodocus? Why does he call it Diplodocus?
I call it Diplodocus.
Is it Diplodocus?
Yeah, that's how I grew up.
Diplodocus?
Diplodocus.
Is it a
Think
north-south
how strange
thing?
and odd he was. They said that 2/3 of his body was submerged so the beastie could swim. That's the Diplodocus.
Yeah, that was the old idea. He's out on the ground now.
He's out on the ground now. He's outed.
He wanders across. He wanders across the plains. He doesn't go anywhere near
paddling
water.
Morecambe Bay, nothing like that at all.
No.
Oh,
Did they live in Morecambe then?
Morecambe Bay.
You see, I've got a great gag now, but I can't do it on the radio. You see, if this was the telly, they used to move like this. So that's brilliant, gag.
And for the listeners at home, Ross Noble just did a mime of the famous Eric and Earn dance. See, it'll work fine. Let them do the,
Yeah.
things.
I'll be
That's
working
Radio 4
entirely
listener.
visually tonight. Good luck with that.
That's interesting what you said, Eric, there, that the change, what we understand about the behaviour of these dinosaurs has changed in just a few years. And the very notion we're talking about, geology, the notion that there was such a thing called plate tectonics, the notation that the Earth is this sort of plastic structure and the continents move, is recent.
Well, it is recent, because when I did A-level geography in 1962, it wasn't yet a theory. It was just like a vague rumour. People were working, and you looked at the Earth, and you thought, well, they'd look pretty close. And so one speculated this was new knowledge, but it wasn't until after I got A-level that they actually said, yes, this is indeed the plate tectonics, and the Earth was actually all connected like that.
Yeah, but most scientists didn't accept it either then. They took a lot of convincing. And in fact, even though the fossil evidence showed that there were dinosaurs over in North America and Europe that seemed to be the same, and lots of other animals, especially in South America and South Africa, in order to explain these distributions, people would invent land masses that had subsequently subsided and sank below the Atlantic Ocean.
Hermione, why do you think that is? Because when you look at a map of the Earth now, it looks obvious that South America and Africa fit together, and Europe and North America
and
fit together.
It's not even just that sort of jigsaw fit that seems obvious now with hindsight. Some of the geophysics that came about in the 50s and then developed into plate tectonics in the mid-60s, you kind of look back on that and think, why did it take them so long to put it all together? But I think one of the problems was that the idea of continental drift, as it was first called, had been put forward as early as 1915 by the German guy Alfred Wegener. But it wasn't translated into English until 1924, so that's really when I suppose the English-speaking geological community started looking at it seriously. But what Wegener could never do, and what was the big stumbling blocks for tectonics, was that nobody could explain how the continents moved. And I know that when you would have been going up to university, Eric, in those early 60s, most people didn't believe in continental drift because although some of the evidence we now know was spot on, it was just nobody could explain how it worked. And the problem was that Wegener put forward some ideas which were sort of clearly very unconvincing. So that gave people the ticket, if you like, to dismiss all his other work.
Yeah, this wasn't really his area of expertise. Was he an astronomer?
He was a meteorologist, mainly. He worked in Greenland, and he froze to death on the Greenland ice cap, aged 50. So things could have been different, perhaps, if he had lived and worked more on his theory.
Or if he died earlier.
But wasn't it... it was... Agassi? Not the tennis player, it was the
Louis Agassiz. He's a big figure in the history of
because he was doing ice, though, wasn't he? He was doing ice moulding.
Yes, he saw striations up in Edinburgh. Edinburgh is very central to lots of kind of developments in geological theory. He also did a lot of work on fossil fish and things. But there were lots of people who were thinking about this at the time and earlier. But it wasn't until the 50s and the 60s where it all sort of clicked together. But the point was, going back to that point you made, Robin, about people working in their fields, prior to plate tectonics, all geoscientists were really working away in their own niche areas, whether you were a geophysicist or a paleontologist or a geomorphologist. You all kind of pursued your own aims. Plate tectonics was the grand unifying theory that brought everything together, and it was the birth of earth science. And now we're all earth scientists. We all work together with a holistic viewpoint because plate tectonics kind of underpins everything we do.
So who was that? Who did that? Who was plate tectonics?
Well, a number of names, but they were all at Cambridge about the same time as you were.
No coincidence. No. I just made a career choice that was wrong, and did comedy instead of...
To be fair, there are not that many plate tectonic experts that are doing all 5 nights at the O2. A lot of them... A lot of them do the Hammersmith Apollo for the odd night, people like it for that, but the big audiences, they don't go with that kind of movement under the sea.
I thought you were going to say, well, I do remember mentioning it at a party to someone.
One of the things about plate tectonic theory was also that most geologists, of course, and paleontologists were investigating the past. But because now there was a mechanism that showed how the Earth works, it also lets you look to the future. And you can track the motion of the continents, and you can more or less work out where they will be 25 million years from now. And that's actually quite a useful tool. I mean, not that we're going to be around in 25 million years, but what Earth scientists can do now, looking at the past with as much accuracy as we can now get with dating, for example, we can monitor global change, and we can make predictions about what is going to happen in the future.
And one of the most shocking things, perhaps, for Eric, is I read somewhere that San Francisco and Los Angeles are going to swap places. Isn't San Francisco moving south and Los Angeles moving north? I mean, that's a place of rapid evolution.
Well, how could they possibly do? I mean, how could that happen?
There's a transform fault where tectonic plates move alongside each other. Uh-huh. If you think about the plates on the surface of the Earth moving around, some are going to be pulling apart, some are going to be pushing together, and some are just sliding past each other. Well, but that was new, and that's why I suppose on the San Andreas fault, it's one of the most famous examples of an exposed...
Well, I was actually in the 94 earthquake, and it was quite something, I must say. Never been so shocked in my life. It was like a huge express train coming in. It went on for about 4 minutes. It was really scary. So I hope this isn't going to happen soon.
Well, why people live on these locations, I'm not sure. I mean...
Well...
Because he's in showbiz.
Yes. It's warmer.
Edinburgh's a great place to live. We've got fantastic geomorphology, and tectonically, you're very safe.
The trouble with Edinburgh is it's all uphill.
Yeah. What was the sticking point? So you say that there were pieces of evidence around, but people couldn't find a mechanism. So what was the problem? Was it the molten core of the Earth?
It was the geophysicists just couldn't work it out. It was what forces are big enough to move continents. Now, what Wegener said and what he saw was the continents sort of ploughing through the ocean floor, which just couldn't work. And we now know, there's so many little bits of information, and what order do you give them in? I think it was in the early 60s, there were disparate bits of information that came together from geophysics.
One of the things that geophysicists did was that they record what's called remnant magnetisation in the rocks. You can record a bit of relic magnetisation from iron minerals. And they found that there had been times when the Earth's north was south, and they detected magnetic reversals. So we knew that the Earth's behaving like a bar magnet, but that at times it flipped. And then, when some surveys were done trailing magnetometers across the Atlantic Ocean, Vines and Matthews out of Cambridge, they found that the ocean floor actually recorded from the mid-ocean ridge that Iceland sits on all the way to the continental shelf a series of reversals, normals. And when they kept the boat going backwards and forwards, they picked up what looked like a supermarket barcode of stripes, in inverted commas. These stripes, if you map them out as, say, black for magnetic normal and white for magnetic reverse, you ended up with this stripy ocean floor. And then you suddenly found that maybe a white stripe was much wider than a black stripe. And then the other side of the mid-ocean ridge, you would find the mirror image of that stripy pattern. And what was happening was that ocean floor was being created and moved laterally from the mid-ocean ridge. And for, say, 20 million years, it was being created under a normal magnetic polarity, and then perhaps for a few million years under a reversed. And then it gave you a method of dating, but it also gave you this sort of, if you like, a conveyor belt of ocean crust.
Can I ask, what causes the flip in the magnetism?
I don't think anybody knows.
Nobody knows. Is it very quick? Is it overnight? Suddenly, we're all living in the north of England.
It's all a bit scary because nobody knows what happens when it
It's grim
occurs.
down south.
But, I mean, is it a sudden thing? I mean, it must.
Well, actually, it's been in the news recently because the Earth's magnetic field is currently weakening, and it could be that we are going into a flip. But probably not in our lifetime.
So what happens if you stand exactly at that point with an Etch-a-Sketch? Come on, science, what you've got?
One of the things that doesn't seem to happen is that extinctions don't seem to coincide with magnetic reversals. So it probably doesn't affect most of the biosphere, but maybe birds that migrate south in the winter go the wrong way. I don't know.
Or if you're halfway through an orienteering kind of event as well, I suppose that's a bit...
Or if you're a giant metal bird. Yeah.
When was the last flip, though? How long are the intervals between flips?
They vary.
They're really variable. There are some quiet periods where it just doesn't seem to happen at all.
20 million years go past, nothing happens. I think the last one was 780,000 years. So you can get sort of 12 flips across 5 million years and then nothing happens.
It could be later on this evening.
Yeah.
But it's quite a curious thing because in many ways it doesn't mean that much. I mean, it means a lot if you're trying to work out the inner structures of the Earth and what causes the magnetic field. But for geology, it's just this fantastic record in the rocks, and you can use it to reconstruct the past position of continents. And so it's actually been fantastic, and it's all happened in the last 50 years or so.
Can you read anything into the fact that you don't see extinctions? Because if it were a slow process and the Earth lost its field for a while, you would expect real problems with the biosphere.
There's no real direct correlation. We find lots and lots of extinctions in the fossil record, and they certainly seem to correspond with periods of rapid sea level rise or rapid sea level fall, and occasionally the odd meteorite impact. But it's the devil's own job trying to actually work out the cause of an extinction. Mass extinctions are pretty tragic things, but you probably wouldn't notice them. In fact, we're living in one now.
Well, is that... just...
Whoa. Let's not just gloss over that. Let's not just... Oh, mass extinctions right now. So, whoa there. Yeah, it's all over.
The end of the Pleistocene, if it has really ended, well, they say it has. They say that we're in the Anthropocene now. So that's
I'm seeing it all
the
the
Pleistocene
time.
and the whole
all
scene
the time.
finished, done with and finished.
All the time I'm seeing that.
We're seeing the extinction of megafauna. I mean, the mammoths have gone and the woolly rhinos have gone, and we're rapidly running out of elephants and all of the other big animals. Part of the extinction is environmental change, but an awful lot of it is man-made now. But we are in a massive mass extinction at the moment.
Well, would it be true, that some people have said that, if you went ahead a million years' time and then the paleontologist of whatever creature might exist then, that looking at the fossil record, it would appear to be that there'd been a comet that had hit the Earth in this particular period of time, such as the damage done by human beings?
If you didn't pick up a record of human beings, if, for instance, they somehow didn't preserve the humans, what we would pick up is all of the radioactivity that we've generated from nuclear explosions and all of our nuclear reactors that seem to be blowing up all over the place. And there would be these elements that don't occur naturally anywhere else. And we'd be looking for an explanation for all these things like, aluminium-26 and all these sort of things that you find in reactors. And you'd find, you go, well, where's that come from? And if you didn't find the nuclear reactors or the atom bombs, then you'd be looking maybe for some sort of extraterrestrial cause.
Can I ask a question on that one, there, on the extinctions? Because it intrigues me. I mean, if that one meteorite that hit just off Mexico, Cancun, isn't it, round there, if that had just missed, would the dinosaurs still be here?
Presumably.
And would they become intelligent? Because why would a little tree shrew become intelligent? And would we now be doing the infinite dinosaur cage?
And I would have spines on my back.
Well, I have.
Without a doubt, the dinosaurs were diversifying. As far as, we know that some dinosaurs were becoming extinct in the Triassic, some dinosaurs became extinct in the Jurassic, but they were always diversifying. And as far as we can see from the record of dinosaurs in the Cretaceous, they were still diversifying right up until their demise at about 65 million years ago. So yes, if there hadn't been that event, if it had gone skimming past the Earth, then they would still be around, and evolution would have taken a completely...
But do we think they might have evolved intelligent life?
Yeah.
It's sort of, we do.
Oh, most people do, yeah. Uh-huh. There was a guy called Dale Russell, actually came up with this concept of the dinosauroid, in which it was a much more upright creature, it lost a lot of its tail, it had got manipulative hands, and we do find some dinosaurs with rather larger brains than... some of the ones which have got the archetypal dinosaur brain, the dim-witted ones, so they say.
Hermione, what's if we run through the fossil record, so the first fossils, I suppose that's the Cambrian explosion, the Burgess Shale, it's what, 540 million or so?
Yes, but actually there is lots of evidence of multicellular life prior to the Cambrian explosion. And some of that was found in Leicestershire by a 15-year-old schoolboy, where nobody believed that you had multicellular life prior to that time.
The Cambrian explosion is a lovely term.
Yeah.
It's a beautiful idea, but it does give you the idea that it was like a kind of volcano just spewing out Muppets. But, it's kind of like it is...
And the fossil record
the explosion's quite... even then it's still quite a long explosion, but I suppose the way that we would view time as human beings over the period of our life.
It really is concentrated within a couple of million years. And we used to think that vertebrates was late on the scene. But now in the Lower Cambrian in China, we've got animals that a lot of paleontologists consider to be the very, very first vertebrates. If they have the potential to be fossilised, i.e. they've got a shell or some hard internal or external skeleton, if they've got the chance of being preserved, we find them down there in the Lower Cambrian. And so all of a sudden, out of very, very simple organisms, we get this massive diversity, this complexity.
This is around 550 million years ago
542,
or so.
I think they say.
Yeah.
Not to put too fine a point on it.
Yeah. It was a Wednesday.
Which is interesting because life began, 3.8 billion years ago or so.
And prior to the
Cambrian...
Cambrian...
Give or take on a Tuesday.
Yeah. Well, Wednesday's half-day
Yeah,
closing, you say. So
But you do find larger animals, the Ediacarans, for example, that are named after the Ediacaran Hills in Australia, where you find a lot of these good fossils that you also find in Leicestershire. These were big multicellular things, but they were presumably just all had soft bodies, so it's very rare to find them.
We don't even know what they are.
No, you're right, because
10 or 15 years ago, everybody tried to slot them, shoehorn them into all of the existing files. Oh, this is a worm. This one, oh, it's a bit circular. I can make a sea urchin out of that if I lose a bit of this and press that in. And then eventually people realised that was just a fudge.
We've got the fossil record begins. We've got some older fossils, but you see this explosion. When do the dinosaurs appear?
It's difficult to say precisely because we struggle to define a dinosaur. Because obviously there's a transition from a thing called a thecodont reptile to a dinosaur. And so people can't make their mind up whether this is the last of the thecodonts and this is the first of the dinosaurs. But if we said in the middle of the Triassic, if I put a figure of, say, 215 to 220 million years, that would be a good start for the age of the dinosaurs.
And what's the definition, though, between the creature you said that came before was
these little
species?
Thecodont reptiles. They're sort of a bit crocodile-like, but they've got their hind legs a bit more underneath them, and they could probably run a fair bit. And people start looking at the structure of the ankle. There seems to have been a dichotomy in what we call archosaur reptiles, and one of them has a sort of a lizard-like gait. A little bit improved, and we call those crocodiles, and they went off on one evolutionary direction. And then there's this other group, and they brought their legs underneath the body. They strengthened the backbone in the region of the pelvis, and they started fusing the sacral vertebrae together. So some people use as a definition 3 fused sacral vertebrae or more. That makes you a dinosaur. But that also happened in pterodactyls as well. And again, that event, that change of the skeleton, seems to have happened somewhere around about the beginning of the late Triassic.
Well, what I find interesting about this field as well is that the precision with which we know, I suppose, the body shapes, the habits of the dinosaurs, even now colours of the dinosaurs. It seems to be, if not precise, then moving very fast. We seem to be getting a lot more knowledge about it. I mean, I remember we were talking about earlier the Brontosaurus. I grew up with the Brontosaurus and then was horrified to find that it seems to have been removed.
There will be a specimen in a museum drawer that was the holotype, the type specimen of Brontosaurus, and that specimen still retains that name. But somebody else has come along, some smart aleck, and said, actually, that is the same as this one here, which is a Patasaurus, and by the way, that was named before, so that has priority.
So could he be the artist formerly known as Brontosaurus?
It could be.
Well, so that's it. He's gone. You can't.
Well, some people find it difficult to let go, and so when they write the name of Patasaurus, they sometimes put after it brackets equals Brontosaurus, close brackets.
This is tricky, right? Because when I get a bag of dino mix now from the garage, and my daughter wants a Brontosaurus, I'm going to have to eat it myself. I'm going to say, sorry, love, you can't have your Brontosaurus.
And Hermione, could you just summarise, I suppose it's very complicated, but summarise, how do we date a fossil?
By association with the rocks that it is within, and then using a whole suite of different radiometric clocks.
So based on radioactive decay?
This was something that really emerged about the 1950s.
So there are multiple ways of dating a rock, essentially, and you cross-correlate them around.
Yes, you can look at different things that have different half-lives, for example.
You've got 2 fossils in front of you.
This is radio, Brian.
Again, superb radio. Perhaps you could pass one to Eric, actually. Perhaps, Eric, for the listeners at home, you could describe what that is or what you see.
Well, it looks like a cricket bat embedded in a piece of mud that got solidified. What is that? That's a different thing, isn't it, that colour?
Well, it's a fragment of dinosaur bone.
This bit is?
Yes, that bit is. So we've got a sort of shiny fragment of bone embedded in some sandstone. And this fossil is dated by association with the rock that it is in. And it comes from the village of Cookfield, where I grew up. And I think that this is probably, by association again, part of an iguanodon dinosaur, because fossils from Cookfield, bones like this, as well as specifically teeth, were what led Gideon Mantell to make the first correct assessment of these fossils and say that they must have belonged to massive land-dwelling reptiles from the past. So that potentially is part of one of the first named dinosaurs.
So an iguanodon...
It's a herbivorous dinosaur. It's very big, several metres long, up to 7-8 metres, I think.
Yeah, and a bit bigger, perhaps.
Yeah, maybe. If you want to find one now, don't bother going to Cookfield, go to the Isle of Wight, because there plenty of nearly complete skeletons have been found.
I thought you were going to say they're still there.
I've done a few gigs on the Isle of Wight. I think some of them were in my audience. This one, we have to get this back by Saturday because it's presenting Strictly Come Dancing.
No, but of course, when Mantell found it, the point about the early discoveries, and really it's sort of a point about the whole fossil record, it's incomplete. So when people Buckland named Megalosaurus for the first time, Mantell named Iguanodon, the very first dinosaurs, they were going on a few teeth and a few bones. And that's why the ideas of what dinosaurs are like and what they look like have moved on. At the time, Mantell thought that was rather a sort of rhinoceros-like creature with a horn on its nose. We now know that Iguanodon was really walked on its hind legs, had shorter forelimbs. The horn on his nose was actually thumbs. So, paleontology moves on with more and more finds.
How much do we know about how they behaved, what they look like?
OK, there's loads and loads of things that we really don't know. Just occasionally, you get a deposit which gives you really exceptional preservation, where you find a deposit where the preservation is not just the bones and all jumbled up, but the bones, all articulated, showing how they related in life, and then soft tissues preserved as well, often a carbon outline of the skin, sometimes showing scales, and of course, with a lot of the dinosaurs now, showing filaments and feathers, and with some very, very precision chemical analyses detecting colour banding and stripiness on some of the feathers that were adorning them. So there's quite a lot about the morphology that we know more than just simply the skeleton. But after that, then we have to do biomechanics to work out how the thing moved. We do that by simply comparative anatomy, comparing it with how living animals move and measuring bone lengths, ratios of upper leg bones to lower leg bones and seeing how it fits in with other animals. But then when it gets down to all of the really good stuff, the behaviour and how they existed, then we need these sort of smoking gun fossils. That's a triceratops bone with a tyrannosaurus tooth in it that tells us that they were hunting them and killing them. But those fossils are really phenomenally rare. And an awful lot of dinosaurs we know from really, really scrappy remains.
But we also have fossil footprints and fossil trackways for dinosaurs, which are, Dave, you'll tell me if this is right, are by far the most common dinosaur fossil, aren't
Absolutely. Every dinosaur left an awful lot of footprints, and if they've got preserved, well, there's quite a life history there. Trouble is, we've never found a dead dinosaur at the end of a trackway.
So it could all be a big con.
But you can work out things like how fast they could run.
Yeah, you can calculate a speed.
So if you're pretty certain and can match up, say, iguanodons with the fossil trackways on the Isle of Wight, for example, then you can start investigating how they would have walked.
And these are some of the best. Those ones on the Isle of Wight down at Compton Bay, I mean, there are footprints that we attribute to iguanodon, and they are enormous. There's one footprint on the beach which is nearly a metre from the back of the heel to the end of the toe. And it's just an astonishingly large animal.
And we have
So that's a 3 footprint.
It's a 3-toed 3 footprint.
Yeah. We have a picture here of a great radio again, but it's an animal that
Let's pass it to Ross. He can explain it.
We've got.
There we go.
Yes, actually, yes.
There we go, Ross. If you could
Maybe Ross and Eric could explain this thing. It's the giraffe.
Oh, right,
thing.
that.
It's a pterosaur.
A pterosaur, which is Dave's. It's one of your areas of expertise, isn't it?
That is basically it's one of the Skeksis from the Dark Crystal, right? Wearing a cape with the head of emu from Rod Hull and Emu.
Eric, have a go.
So basically, you've described a misfits game there, haven't you?
I would say it's a giraffe with a Halloween mask on. It's got a
Wouldn't that be
huge
a myth?
nose.
It's actually a restoration of a pterodactyl called Quetzalcoatlus, and it was discovered in Texas back in the 1970s. And although nobody's ever found a complete one, there's been partial skulls, complete lower jaw, a nearly complete wing, nearly complete neck. And if you take the biggest bones and you scale them up, this is an animal that has a wingspan of 11 metres. That's the same as a Spitfire.
Just to make clear, we're talking about an animal that flies.
Absolutely.
So how does it take off? Does it go up the tree like the Archaeopteryx and drops off, or does it flap its
It had
wings?
such a large surface area for its wings, it could probably just do a little frog-like jump and be airborne.
But just to be specific, the photograph... Oh, the photograph.
I can't believe it. Poor Dave's been working on this for 30 years and he's only just found out it's a hoax.
It takes a long time for your prints to come back.
It was a carnivore, this thing, was it? Carnivorous?
Nobody's ever found the stomach contents of this beast, but if you do an analysis of its skeleton and you kind of compare it with what there is around today, it probably had a lifestyle a little bit like a stork, walking through the fields, eating anything that moved. A stork will take mice and frogs and snakes and things like that. This animal was big enough to take a baby brontosaurus.
Eric, you've lived out in the States and on the West Coast for quite a long time, and I know it's fascinating to think about the number of
Not
fossils...
so long that I've seen one of these, though.
But incredible discoveries have been made, as we just mentioned, in Texas, for instance. And yet, I imagine that it's one of the intriguing things is you must come up to people, meet people who kind of go, well, no, dinosaurs are kind of, it's all been put there just as a kind of test. And
I try not to meet those sort of people. I mean, idiots are everywhere, and not just confined to the western parts of the United States. But yeah, you're right. I mean, people... I mean, I don't understand how they could be so confused when there's so much evidence. It's ridiculous. And it's probably because we always talk about theories, whereas they're always talking about certainties.
But there is also that creationist museum, though. Have you been there with the where they've put dinosaurs and people together, and they've created this whole...
That's called Las Vegas.
Yeah.
Is it widely accepted now that the thing that caused the extinction of the dinosaurs was some kind of impact on the Yucatan Peninsula?
Yes, definitely. I mean, it definitely occurred at that time.
It's a really bizarre extinction because some organisms just went through unaffected. Whilst the dinosaurs disappear, and they disappear just like that, huge parts of the world were unaffected, and lots of organisms that just sort of slipped through.
Or could it be that some of the dinosaurs were advanced enough to say, build an ark? I'm just putting it out there.
we as usual, we haven't got to the...
Well, someone should say no.
Not unless you can't just say no. You have to offer a valid scientific theory.
What you can say is that the fossil record is incomplete. So who knows what we're going to find next?
Well,
it
don't
could be
rule
the
out
ark.
my ideas.
It could be.
Writing that in a new book, which I'll be leaving in hotel rooms.
Just very quickly, I wonder, the sexual behaviour thing. How on earth can you work out what kind of sexual behaviour? What are you using? What are you using in terms of, the shape?
And does size matter?
That's why they got bigger. It was sexually selected.
But
the problem with trying to determine how dinosaurs did it is they don't preserve their soft parts very often, okay? But one imagines that some of the dinosaurs were so bloody big that they needed some sort of a dong in order to reach the cloaca. So ducks, for example, have actually got a sort of pseudo-penis. So one presumes that a lot of dinosaurs must have as well. Just think of the physics of trying to get it together. But we don't have...
I can't get it out of my head.
So there's another way of...
Our duck listeners are going to be furious. What do you mean, pseudo-penis?
Put it on your bill. I think we should take your knowledge and you and I should make a sexy dinosaur film.
We should make a pop-up book.
Jurassic Pork. Sorry, carry on.
There's just one... This is something that fascinates... When I read Dragons of Eden, the Carl Sagan book from about 1978, he did say there was one theory, which he didn't really go with, but I want to know if he'd still ever thought about that. The dinosaurs actually died out because there was a plant which they used to eat, which used to help the digestive process, and the plant died out, and that all the dinosaurs died from constipation. Is that still ever played with as an idea?
That probably is close to the truth.
Is it?
No.
Oh, that's amazing. I just think walking with dinosaurs would have been so much better. Oh, God, I can't. This is ridiculous. I can't even walk.
It'd be more like sitting with dinosaurs, squatting with dinosaurs, wouldn't it?
So we asked the audience, if you were a geologist, what would you like to find under a rock? Pat E says paper rather than scissors. We may end there, Pat. It's never gone that well for a first one.
You know where there's worrying ones sometimes, and you think, I'm not going to actually walk out into the audience because my safety might be threatened. Someone here says, a piece of paper, a pair of scissors, a lizard, and Leonard Nimoy.
Are you reading out the Scientology Bible?
That'll do. Oh, a turtle, then another turtle, then another turtle, all the way down. So, now we've actually got some letters as well. Are we going to do with them today, or should we just go straight to the end of the show because we've got so much to deal with anyway? What do you reckon?
Do letters next week.
We'll do letters next week.
Yes.
We had some. I'll tell you what. Let's just give them a little sample of the letter. These are the kind of letters that we get in, and they are fantastic. We've got. Where's the?
These are real letters. Dear Mr. Cox, I have been thinking recently about how things move through space and time, and there's something I've been struggling with. Imagine you want to get from A to B. If you divide the distance by the time taken between A and B, you get C. Therefore, you must travel through C before you get to B. Similarly, along a path from A to C, there will be another point halfway, point D, and so on. I'm not a scientist. Kind regards, Philip. Dear monkey folk, I've just re-listened to your last podcast in the Science Museum. The show ended with a guest asking the question, can chimps do trigonometry? And everyone agreeing with the idea this was ridiculous. I would like to challenge this. Chimps most certainly can do trigonometry, and they can do it far better than me. Kind regards, Dan, evolutionary biologist. I rest my case.
Thank you very much to our guests, Hermione Coburn, Dave Martell, Ross Noble, Eric Idle. Next week we are Pie Curious with science writer Simon Singh, mathematician Colver Roney Dougal, and legendary comedy producer John Lloyd. Thank you very much for listening. Goodbye. That was the Infinite Monkey Cage podcast. I hope you enjoyed it. Did you spot the 15 minutes that was cut out for radio? Anyway, there's a competition in itself. What, you think it should be more than 15 minutes? Shut up, it's your fault. You downloaded it. Anyway, there's other scientific programmes also that you can listen to.
Yeah, there's that one with Jimmy Alka-Seltzer.
Life Scientific.
There's Adam Rutherford, his dad discovered the atomic nucleus. That's
Inside Science, All in the Mind with Claudia Hammond.
Richard Hammond's sister.
Thank you very much, Brian. And also Frontiers, a selection of science documentaries on many, many different subjects. These are some of the science programmes that you can listen to.
A little leg up in his career. It's Eric Idle, and this is our panel. Hermione, the understanding we have of the processes that formed Earth today, and I suppose the age of the planet, we quoted that number, 4.54 billion years, very precise. But it's relatively recent that we built up that picture, isn't it? So can you run through the recent history of geology?
Well, there are so many different ways to answer that question. But I think if you're looking at kind of the start of geology as a really systematic science, I think you probably have to go back about 200 years. To the end of the 18th century and to James Hutton. And he was a Scottish geologist, but I sort of hesitate to say geologist because actually he was more than that. He was a farmer, he was a naturalist, he studied medicine at Edinburgh University. So he was very practical as well as academic. And what he did by looking in the landscapes and the rocks around Edinburgh was really challenge the notion of a young Earth. Because at that time, there was this idea that the Earth was probably created about 6,000 years ago. And this all came from sort of the religious framework of the time. But what Hutton did was he said, look what's in the rocks. There simply isn't enough time in 6,000 years to explain what you can see. And what he saw was phases of uplift, long phases of erosion and sedimentation, and all the geological processes that we now know go on and take a very long time. So I suppose he was really the first person to open up the vastness of geological time. And then you had people like Charles Lyell coming in. I mean, I suppose he could be argued to be the start of geology as a science. But that early 19th century was the boom time for geology.
And it's interesting that if you look back, it sounds like a long time ago, but tips.
Which later changed its name to New Tricks.
Is this a real show? Is this actually a real show?
It's not normally.
Because I've seen you do stand-up and I've seen him on volcanoes and that, but this doesn't seem legit.
No, it's not at all.
It's all in voiceover, my stuff.
Ross Noble is Twitter's very own littlest hobo, going from town to town and place to place on the whim of his followers. Starting in stand-up as a teen, he was something of a child prodigy. He's now an inner child prodigy, refusing to allow his inner adult to in any way take charge of his life.
Oh, that was me. Yep, lovely. Yep.
Now, it could be said our final guest needs no introduction, but that'd be poor radio, because you'd be sitting at home thinking, I know that voice, but who is it? We're always keen to support emerging talent.
He's just starting in the business very much.
So we're giving him a
Get a joke if I were you.
Yeah,
Beyond the dinosaurs, we'll be digging down into the soil beneath us and seeing how the rocks below create a time machine, a vision of life and a changing planet that allows us to understand that the Earth is 4.54 billion years old and has a fascinating history. Dave Martell is a professor of paleobiology. He was an advisor on Walking with Dinosaurs and is an expert on mitochondrial DNA and dinosaur sexual behaviour.
I didn't know that.
Is that not true? No. It says it on your website, your university website.
Did it? I love a word with the IT people. I know a little bit about sex in dinosaurs.
But that probably means you know more than almost everyone else. To know a little bit about the sexual behaviour of dinosaurs still puts you in the lead.
Do you think we'll ever get to the end of the introduction? Hermione Coburn is a geomorphologist and was presenter of BBC's The Fossil Detector.
Hello, I'm Robin Ince.
And I'm Brian Cox.
And welcome to the podcast version of The Infinite Monkey Cage, which contains extra material that wasn't considered good enough for the radio. Enjoy it. On my left, a man who's seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion, sea beams glittering in the dark near the Tannhauser Gate. He is, of course, Professor Brian Cox.
On my right, a man who's experienced delays between Stevenage and Grantham due to points failure at Peterborough. It's Robin Ince. Today we're going to talk about the history of life on Earth and the history of the Earth itself. After 8 series of endless physics, particles, muons, gluons, quarks and probability, finally we get to the science. You wrote this, didn't you?
Yeah, I did. Yeah, it's real science. This is dinosaurs. And you may say, oh, but they didn't have a space program. Isn't that just what you would say? Anyway, dinosaurs are better than physics.
He took my joke, didn't he?
I'm just trying to speed it up.
He took my joke from the...
OK, you can do it. I'll let you do it. I'll let you do it.
No, there's no point now, is there? Because I've done it once anyway, and now you've done